Our lesson for today deals more with what we've been dealing with, and that's factoring our graphs, looking at the degree, your leading coefficient to determine your end behaviors, finding your roots, all that good stuff. It's just the roots aren't always going to work out as nicely as they did in our day 4 notes. Sometimes they're going to be irrational or complex. So remember, irrational means you have the square root of a non-perfect square. Complex means the letter I is going to be in your answer. So we're going to start having some of those kinds of roots. So if we take a look at our first example, we'll go through and answer the questions they want us to answer, eventually getting down to the fact that they want us to sketch our graphs. So first one, what is our degree? So if we look at that leading term, our largest exponent there, we have a degree of 4. But next part, they want us to figure out the end behavior. But remember, to do the end behavior, we got to look at our leading coefficient. So if we look at our leading coefficient, it's a positive 1. So that means I have an even degree, positive leading coefficient. Both of my end behaviors are going to be going up. So I'll write it this way to help us practice that notation. So as x approaches positive infinity, the function approaches positive infinity. Remember, this is fancy for our right side. As x approaches negative infinity, which is our left side, the function approaches positive infinity. So again, this is just saying left up, right up, but we have to write it in this notation now. So they want us to determine how many roots are there. Well, degree is 4. So there's 4 roots. Not all of them are necessarily real numbers. We could get some complex numbers in there. So next they want us to find the roots. All right, so I'm going to start by trying to factor. So I have x to the 4th plus 8x squared minus 9. So I'm going to factor this, and it factors into x squared plus x squared minus. The things that multiply to give us 9 are 3 and 3, but I can't get an 8, so I'm going to use 9 and 1. And then 9 minus 1 gives us our 8 for our middle term. So then I asked myself, can I factor again? And I can with this one, but I can't with this one. It looks like you can, but because of that plus sign, I actually cannot factor that again. So I get x equals negative 1, x equals positive 1. Those are the easier ones for us to figure out. Over here for this one, when I set it equal to 0, here, you know what, I'm going to do this one over here where there's a little bit more room so you guys can see it better. So when I set it to equal to 0, I subtract my 9 over. So I get x squared equals a negative 9. Take the square root of it, but remember, when we take the square root, we get a positive and a negative. Because it's negative, we get an I in there, so it's going to be an x equals positive or minus 3i. So when it tells us to describe our roots, we have 2 imaginary roots, and then we have 2 real. To go even further with our 2 real ones, these ones would be rational, and they would be unequal. So now down here they want to know how many x-intercepts do we have. Now we did find all 4 roots. However, imaginary numbers never actually touch or cross your x-axis. So as far as x-intercepts go, there's only 2 x-intercepts here, and it would be your 1 and your negative 1. So now they want us to sketch the picture of our graph. So I'm going to draw my axes in there. Oh, I didn't mean to do that. So when we go to sketch our graph on this, the only ones we can plot are the negative 1 and the positive 1. And as we said, our end behaviors are both going up. So the left side needs to be going up, and then it's going to come down, loop around, and then go back up that way. And there's the sketch of our graph. Now, if you wanted to, you could take a look in your calculator, and your calculator is actually going to show you the same exact kind of picture. So let's take a look at our next one. So they want to know how many roots are there going to be. Well, if I look right there, there's going to be 3. So they want us to find our roots. So x cubed minus 8 equals 0. So now this is factoring our perfect cubes, which you guys need a little bit more practice on. So we've got to find the cube root of both terms. So that's an x and a 2. So it's going to be x minus 2, then x squared plus 2x plus 4 equals 0. So now when I go to finish solving this side's easy. I just get x equals 2. This one, it can't be factored again. So you need to solve it either by quadratic formula. I'm a really big fan of using completing the square. So I set up to do that. I brought my 4 over, and then I put my spaces in there. So then 2 divided by 2 is 1. 1 squared makes me put a 1 in there. So now that factors into x plus 1 squared. And it's going to equal a negative 3. Take the square root, and I get x plus 1 equals plus or minus. Because of that negative, I'm going to pull my I out. 3 is not a perfect square, so it's going to stay as radical 3. And then my last step is to subtract my 1 over. So I get negative 1 plus or minus I radical 3. I like completing the square because I feel like it is much faster than if I had done the quadratic formula and gotten the same answer. So for sketching our graph, I got to set it up. We got to think about what our end behavior is going to be. It's a positive leading coefficient. Leading coefficient is positive. So that means our right side should be going up. My left side should be going down because it's an odd degree with a positive leading coefficient. Again, that's just a chart you guys need to memorize. So the only dot I can put on here is at my 2, because these two over here, your negative 1 plus the I radical 3 and negative 1 minus I radical 3, those are imaginary, so you can't really plot those. And so then we only have the one that we can go through. So there's the sketch of our graph for that one. Now, one thing you can do for this to try to make your graph a little bit more accurate is you can go through and find out what your y-intercept would be. Remember, to do that, your y-intercept is where your x equals a 0. So if I were to plug in a 0 for my x, I'd get a negative 8. So you want to make sure that that crosses at negative 8. If we did that for the first one up here, found my y-intercept, it'd be 0 to the 4th plus 8 times 0 squared minus 9. So we'd get 0 plus 0 minus 9. So this would be at negative 9. So this should cross at negative 9. That's just one thing you could do to make your graph a little bit more accurate. All right, so let's take a look at example 3. So we're given our polynomial here. They helped us out by factoring it to this point for us already. So first question, how many roots should we have? I like to look back to the original. We should have 4 roots there. So next up, they want us to find the roots. So I'm going to take the factored form, because that's going to help us out. And I'm going to go ahead and find my roots. So again, I can already tell both of these are not going to be factorable. The only way to multiply to get a 5 is a 1 and a 5. That's not going to give you a 2 in the middle. For your 10, you got 1 and 10, or 2 and 5. Again, that's not going to give you a 6 in the middle. So I'm going to use, once again, completing the square. So this would give me a 1 and a 1 So this would be x minus 1 squared equals negative 4. Take my square root. X minus 1 equals plus or minus 2i. Add my 1 over, so x equals 1 plus or minus 2i. And you always want to put it in that order. Your I always needs to come last. So then over here, again, I'm going to do my completing the square. So 6 divided in half is 3. 3 squared is 9. So I have x minus 3 squared equals negative 1. So I take the square root. X minus 3 equals plus or minus I, and then add my 3. So there's our roots. All of them are imaginary. Alright, so when it comes to sketching our graph for this one, we don't have any x-intercepts to use because all of our roots were imaginary. The only thing we really have to go by is if I plug a 0 into this, my y-intercept is going to be a 50. So there's 50. It is an even degree with a positive leading coefficient. So we just kind of make sure it goes through 50, make sure it doesn't touch your x-axis, and kind of curve it back up. That's going to be the sketch of our graph when all of our terms are imaginary. If you're not sure about that, you can always check it in your calculator. Remember, that's also always an option. So let's take a look at this down here. When you're writing the equation given the graph, your equation should be in factored form. Do not multiply it all out. Just leave it like that. It's going to make your life easier. So you got to think about the shape of the graph, end behaviors, zeros, the multiplicity of the zeros, whether it's touching or crossing. So let's take a look at our examples. So we have here roots at negative 3, 0, and 2. So I want to kind of make myself a little chart. At 3, it's touching, but at the other ones, it's crossing. So if I think about the minimum that it could possibly be with a touch, the minimum would be a 2. With a cross, your minimum exponent would be a 1. So we're going to go with that. You always want to go with your minimums when it comes to writing the equation of it. So for my equation, I'm going to write f of x equals. When I put my root of negative 3 back in there, remember it turns signs, it changes signs, and it becomes positive. So that would be x plus 3 squared. Because remember, if I took x plus 3, set it equal to 0, I would get back up here at my negative 3. And then my x equals 0, well, I wouldn't write anything with it. It would just be x, and then to the first. And then my x equals positive 2 means it would be x minus 2, and then again to the first power. So that would be my possible equation for that graph is x plus 3 squared, x to the first, and then x minus 2. Another way we could write it is you could put the x out in front if you wanted to rearrange it. You're more than welcome to. You don't have to put the exponents of 1s all either because it's always an assumed thing. So this would be an equivalent form that you could do. Both answers would be accepted. Let's take a look at our next one. We got 1, 2, 3. All right, so let's write these out again. So I got x equals negative 2, x equals 0, x equals 3. It crosses for all of them. So my lowest exponent possible would be a 1. If we're taking a look at this, I can tell it's going to be an odd degree because my left side's down, right side's up. They're going in opposite directions. And the fact that it's left down, right up, that tells me it's a positive leading coefficient also. So when we go to write our equation here, again, changing our sign, so x plus 2, and then times x, and then times x minus 3, all to the third power. Or, I'm sorry, all to the first power, giving us a total degree of 3. Again, if you wanted to rewrite it and just put your x out in front just because that's how we're normally used to seeing it, you can, but either one is perfectly fine. And then our last one, instead of giving a picture, if you were given different clues, you have create a cubic equation that has a double root at 1 and another 0 at -2. Okay. So if the double root is at 1, when I put it in my parentheses, it's going to become x minus 1. It changes signs. And since it's a double root, I'm going to use an exponent of 2. And then my other 0 at -2 would become x plus 2. And that would be my equation. And then we know it's cubic, because if you add your exponents here, 2 plus 1 gives you 3, which is a cubic equation.